Okay, so on the board what we have is f of x, which is a quadratic function, and g of x being a linear function. Now, a very, very typical GCSE question, and the theory that we're going to use applies if these are exponential graphs, if they're quadratics, if they're cubics, reciprocals, and even if you have one of those really weird graphs that comes out, the same theory applies. Now, first of all, what I want to do is I want to solve when f of x equals g of x, i.e. I need to find the x values for which these two lines are the same. So what I'm going to do is I'm going to find out where the two lines intersect one another. So there's one here at about minus 1.6, and there's one here at about 3.7, roughly. Now, your values will vary slightly depending on how well you've drawn the graph. Mine is a sketch and I've done it freehand, so chances are it's not going to be exactly right, but the theory is correct. In the exam, you have lots of vertical lines. You can use a ruler. It makes it a lot more accurate. Now, in the second part of the question, we have an inequality. F of x is less than or equal to g of x. So what that means is I want the graph, the blue line, f of x, to be smaller than the red line. So if you look here, for example, the blue line is bigger than the red line for a given value of x. So we're not looking at this bit. Same theory, we're not looking here. If we take x anywhere from minus whatever your answer was, 1.6, up to 3.7, anywhere here, the blue line is below the red. So if we took x equals 1, the blue line here is at 3, and the red line's up at 8. Therefore, the blue is less than red. That's great. You need it for any x value that's true for. So the inequality is basically from minus 1.6 up to 3.7. Anywhere there, it's true. Now I want it less than or equal to, so again, I will put less than or equal to it. 3.7. Finally, we want to draw the tangent to f of x, that's the blue line, at x equals 2. So at x equals 2, y is at 6. So we know the coordinate to 6. That's really important. Okay? Now, what we're going to do is we're going to draw the tangent. And it's really important we do this properly. You put your ruler on the line at the point x equals 2. The tangent has to touch f of x at that point and that point only. And it needs to basically be the same gradient. So when you put your line on, the gap either side between the line and the ruler has to be about the same. Okay? If it's like this, clearly that's not right, it's not following the curve. If it's like this, it's not following the curve. So put your ruler on, oops, and draw the line. Okay? You can see, well actually that's possibly not completely correct, possibly needs to be a little bit further out. So if we draw it again, if you're using a pencil, this would be a lot easier because you can just erase it. Okay? That is the tangent. That's the tangent there. That red line. You probably want to extend it on a bit more. Okay? Again, using a ruler, not like me, don't do it freehand. But that red line is the tangent. Now it says we want to write down its equation. So I can use y minus y1 is mx minus x1. I know x1, y1 because it passes through this point. So that's x1 and that's y1. All we need to do is find the gradient, which is rise over run. So take 2 points on the tangent. Let's take this point. That's 1, 2. And we'll take this point. We know it's on the tangent. That's 2, 6. So we take this point, 1, 2. And we take this point, 2, 6. The rise is the change in y, that's 4. And x, the run, goes from 1 to 2, so it's 1. Meaning the gradient is 4. So I can replace x1 with 2, y1 with 6, and the gradient with 4. Y minus 6 is 4, x minus 2. Now, if you don't draw the tangent correctly, it will be slightly off, the gradient will be slightly different. Okay? If you don't choose exactly the right points on the line, again, the tangent will be wrong. You have to choose very, very specific points. You have to make sure your tangent is drawn correctly. You can see that the gap either side, just either side, is about the same. And that's how you know you've drawn the tangent correctly.